can go on there.
Hello everyone. Today let's discuss the binary search algorithm. Right. So previously we had discussed about the linear search. Today we'll be discussing about the binary search. So what is the binary search algorithm? What is binary search algorithm basically does? Binary search algorithm is used to find the position of the target value within the sorted array. So make sure that the array has to be sorted at any cost to make use of the binary search algorithm. So to search the target value within the sorted array, we'll be making use of binary search. So we'll be implementing binary search only if we are having the sorted array. So we have to keep this in mind, and also it will work by repeatedly dividing the search interval in half. So first we have to find the middle element, then we'll be searching left, and then we'll be searching right. And if the element is found middle, then we'll be returning the same element. So this will be left, this will be right, and the middle. So the second step is it works by repeatedly dividing the search interval into halves, right? So this will be the first step. You have to remember that we have to implement the binary search. We can implement the binary search only when the array is sorted. And second step is it works by repeatedly dividing the search interval in half. So if the value of the target is less than the item in the middle of the interval, then narrow the interval to the lower half, or this one left. And if the otherwise, narrow it to the upper half, nothing but the right, this one. So repeatedly we will check until the target value is found or the interval is empty. So until that we will be carrying on the operation. So this is what we will do. Let's try to write the algorithm, and let's try to implement that one in the code and try to understand with the example, right? I'll just remove this one. So let's try writing the code with the example, and let's discuss this with the example, and also finally let's discuss the time complexity and the space complexity as well. So let me give here, this has to be function. Let me give binary search. Let me take the parameters array and target. So here initially, let me initialize left to 0 and right to the last element in the index. So here this will be I have considered array, right? The length of the array minus 1, because the length starts from 1. We are considering the last element in the array, nothing but array.length minus 1. Next, we will continue searching while the search interval is valid. Nothing but left has to be less than or equal to right. So I said that we can implement only the binary search when the array is sorted, right? So here we can write in this way, while left is less than or equal to right. So it has to be less than or equal to right. So then we can perform these operations. So here this can be to find the mid element. I can just write left plus right by 2. This is just. So I hope this is clear. Next, what we will do, if the middle element is the target element, then we can just return mid. So here this one, array of mid equals target, then we can just return the mid, right? So else, if the middle element is less than the target, we have to narrow the search to the right half. So how can we write that? Else if I'll give array of mid is less than the target, then we will narrow the search to the right half, right? Right half is nothing but left equals mid plus 1. So finally, if the middle element is greater than the target, we will narrow the search to the left half, nothing but right equals mid minus 1. So here I'll just write else right equals mid minus 1. So I hope this is clear. So if the element is not found in the array at all, so then it it will be failure and we will be returning -1 if the no target is found in the array. So I hope this is clear completely. This is it. Then let's check with the example. So I'll just give here, I'll just consider array. Let me consider 2, 5, 7, 9, 11, right? So this is the sorted array. As you can see, this is sorted in the ascending order. So let's consider the target value that we want to search for. So I'll just give here the target equals 7, right? So then finally I'll just give index equals binary search function. The parameters that we have is array and target. Let me mention this one here. Finally, we have to output the sorted array as well as we have to output the result of the search. So I'll just make use of the console log quickly, and let me give like this console log of sorted array, this one, and let me call the array here. Also, we have to output the result of the search as well, right? So for that reason, again, I'll be making use of console log here. I can write in this way. So I'll just make use of the string interpolation. Let me remove this one, double inverted comma. Just make use of the backtick here. We'll just mention the target. This has to be small t, right? I have considered small t. This is fine. So at index, where did this backtick go? Yeah, this is fine. So I'll just give here index. So let me give comma here. So yeah, this is fine. We have to get the index 0, 1, 2, right? At the index 2. Let's see. So yeah, you can clearly see here, we have given the sorted array 2, 5, 7, 9, 11 and target 7 found at index 2. So here you can clearly see 0, 1, 2. At the second index, we are having the value 7, right? So we are getting the correct value. So this is it. This code works absolutely correct. And then let's discuss this one, time complexity and the space complexity. So the time complexity would be big of log n. Why it will be big of log n? Because the search space is halved with each step. So in the each step, we will be splitting into 2 hops to search for the particular target, right? So the search space is halved with halved with each step. Then the overall time complexity would be big O of logarithmic n. So I can just write here big O of log n. Let me leave the space over here. And also, what will be the space complexity? The space complexity would be big O of 1. Why big O of 1? Because we are making use of constant amount of additional space here. So that is the reason the space complexity would be big O of 1. So this is it. Thanks for watching, guys.